Yeah. All right. How you want to do it?
I got audio set. Let's start there. Start working our way down through.
You know, just do questions or segments at a time, or just
Yeah.
okay. You.
Yeah, and that'll give you a good placeholder too, right?
Is that?
That would be. These are actually the message points that we want to drive home.
Okay.
What do you think? You want to start with where the actual outline begins, and then come back and hit some of these?
All right.
Okay. We are rolling.
Okay, so the first one would be, what is grounding?
Grounding is more of a general method. It's often used in the industry to describe a method of which someone used to connect equipment or some type of system together, rather than a specific term. People talk about a grounding conductor or a grounding system, or I grounded that box, or I need a ground rod for this device. Grounding itself gets drawn up in a general term, versus during the course of the presentation we're going to talk about specific terms and how they differ from point to point.
Okay.
Let's hold for a second. Let this airplane pass.
Yeah, we have to fight the airplanes.
Yeah, I understand.
Okay.
How do you feel about that? Is that a good format for you?
Yep. You're gonna make this job very easy.
Pardon?
I said you're gonna make this job very easy.
We try to.
It's difficult with a lot of people, believe me. Okay, so what is bonding?
Bonding is another term that's confused. Often bonding and grounding are used as an interposing term. In fact, bonding per se is where you're connecting equipment to each other, basically equipment to equipment, versus not necessarily to ground. For example, I can have various pieces of equipment bonded together and doesn't naturally have to have contact with Earth at all. You can use an example of an airplane. The airplane is not in contact with Earth when it's in the sky, but all the pieces on a plane are all bonded together. There is a methodology of bonding equipment to things that have no contact with Earth at all. Even the space shuttle, it's not even in contact with the Earth. But equipments have to be bonded together on a space shuttle to reduce the effect of magnetic induction with various parts. And we're going to talk about those terms and how bonding specifically differs between grounding. Okay.
So did that cover what is the difference between bonded and grounded?
Yeah.
Okay.
Bonded is basically the interconnection of different pieces of equipment, metallic parts, for example, bonding of a pipe together with an electrical system, or the frame of a building to an electrical system, or the frame of a building to a water pipe, or a water pipe to a gas line, or different metallic enclosures, be they pipes, vessels, boxes. They could have electrical equipment in them and not. But it's the bonding where everything is electrically connected together by a conductive means, usually a grounding conductor. Sometimes it can be other pieces of metal that bond things together, terms like conduit or the pipes themselves. But a bonded is where everything is at equal potential relative to each other. How's the voice going? Is it
Good.
Steady state? Okay. Grounded is actually referring to a connection to Earth. For example, I can have a bonded system, as I said earlier, that's not in contact with soil at all. When something is grounded, it actually has a means of direct or indirect connection to the physical planet, the Earth.
Okay. So what is the purpose of a bonded grounding system?
Well, there are actually 5 purposes. There are 5 basic principal reasons for an effective bonded and grounded system together via low impedance path connection to Earth. Principally, the first one is when we think of a power distribution system, the system ground is stabilizing the XO point of a transformer. For example, most transformers employed in North America are 3-phase 4-wire Y systems. The system ground is the connection of the XO terminal to Earth to stabilize the system voltage. It's called the system ground. It's actually a fairly new definition. It's been employed for decades, but it's a fairly new definition that was employed in the 2005 electrical code. The second purpose of an effectively bonded grounding system is so that you have an effective path for ground fault currents to flow in a relatively controlled path from the point of the fault back to its source. And I use the term relatively controlled versus an uncontrolled environment, where because the point of the fault, you're going to have ground fault return in a variety of paths, but you want an effective grounding and bonding system so that you can somewhat control how the ground fault is routed between the point of the fault to the point of its source. Another point, point number 3, is where you want an effectively bonded grounded system so that your overcurrent protected devices will operate as designed and intended. For example, if you have a lot of impedance in your bonding and grounding system, then you can actually prevent your overcurrent protected devices from actually operating. They won't sense enough current to actually actuate. In fact, it's a common problem in the power distribution system as it relates to Schneider Electric. I've been on numerous sites in which we had to investigate breakers that there were claims against Schneider Electric that the breakers did not operate as designed and intended during an actual ground fault condition, only to find that there was so much impedance in the grounding and bonding system that the breaker could not sense the amount of current for which it was set at. That was a maintenance and installation issue, not a functional issue of our breakers. The fourth reason is you want everything bonded to equal potential such that there is no difference of potential between dissimilar metals. It's called the equal potential plane. There's no step gradients. People can actually be shocked when there is a surge event standing near a piece of equipment, or they can have difference of potential, and that's often what causes damage during lightning storms or ground fault conditions. Or, for example, I'll use the example of the static shock. You shuffle your feet across the floor and you touch something. Discharging that energy, everything is at a different potential. A grounded and effectively bonded and grounding system keeps everything at equal potential such that you don't have a voltage difference. And if you don't have a voltage difference, you don't have current flow. Hence, no damage, no shock, no problems. The fifth reason is to limit potential rise during an abnormal condition. For example, a direct lightning strike, an indirect lightning strike, a surge switching event from a utility operation. Could be normal, just switching loads from one side to another side of a power distribution system, opening up circuit breakers can cause switching transients, or a commingling situation such that you have different voltages actually in contact with each other. The classic example is where you have an overhead distribution line that one of the line drops during a storm, a person hits a power pole, or there's a wind damage, a limb falls on a power line, and that higher voltage line touches the lower voltage line. For example, in your home, you may have what they call the service drop coming off a pole. If the medium voltage line were to touch your service drop, then that higher voltage is commingling with the lower voltage, and it can create some very large potential rises inside your home to the point of setting your house on fire. We recently had an event where there was a substation that was struck by lightning, 161 kV substation, that in the point of 6 minutes was struck by lightning 4 different times, causing a 30 MVA transformer to explode and catch fire and burn for 3 days. There was a commingling of the higher voltage 161 kV voltage with the lower voltage 13.8 voltage. That's an example of commingling of different voltages. Usually most commingling occurs in facilities where you have a 480 volt commingling with a 208 120 volt circuit, or a 208 120 volt circuit commingling with a 24 volt control protective fire alarm circuits. Those are all types of commingling. And an effective bonding and grounding system limits the voltage when you commingling. Is that too much? Okay.
More the better, because that gives us a lot of variety.
Okay.